Good morning to everyone. So last class we have seen the LPC2148 features and pin diagrams and vector control and USB that features. So interrupt control logic. So in this we are going to see about the pin connection block. The pin connection block allows the selected pins of microcontroller to have more than one function. So the configuration registers control the multiplexers to allow connections between the pin and the on-chip peripherals. So the peripherals should be connected to the appropriate pins prior to the being activated and prior to any related interrupts being enabled. So activity of any enabled peripheral function that is not mapped to a related pin should be considered undefined. So the next one is the fast general purpose parallel pins, that is called GPIO. So in LPC 2148 and 46 or 48 in any configuration introduces the accelerated GPIO functions in LPC 2000 devices. So the GPIO device registers are relocated to the ARM location bus for the fastest possible IO timing. So the mask registers are allowed treating sets of port bits as a group, leaving other bits unchanged. All GPIO registers are byte addressable. So entire port value can be written in one instruction. Features. So bit level set and clear registers allow a single instruction set or clear or any number of bits in one port. So the direction control of individual bits, separate pins, separate control output set and clear. So all the IO default to inputs after reset. So the next one is ADC. So ADC stands for that analog to digital converters. So in LPC 2148, there will be a 10-bit ADC. So in that 10-bit ADC contains two analog to digital converters. So these converters are single 10-bit successive approximation ADC converters. So the ADC has 6 channels and ADC 1 has 8 channels. In the total number of available ADC pins, LPC 2148 or 46, 6, and for LPC 244, 46 or 48 is 14. Then features. So the 10-bit successive approximation ADC converters measuring the range of 0 to V reference 2.5 volt. So each converter capable of performing more than 4 lakh 10-bit samples per second. So every analog input has a dedicated registers to reduce the interrupt overhead. So burst conversion mode for a single or multiple inputs. So optional conversion on transition or input pin or timer match signal. So the global start signal command for both converters. So the next one is 10-bit DAC. Okay, so these are all the USB and features we have seen. Okay, so the next one is watchdog timer. So the purpose of watchdog timer is to reset the microcontroller within a reasonable amount of time if it's enter an erroneous state. So the next one is the features we have seen, the real-time clock, timers. So in the timers, the LPC 2148 has a timers and counters. So the LPC 2148 has a 2-bit timers and counters, timer 0, timer 1, counter 0, counter 1. So the LPC 2148 timer has a input of peripheral clock or an external clock. So it counts the clock from either these clock sources or its operations. So the LPC 2148 timer counter can generate an interrupt signal at a specified time value. So also the LPC 2148 capture registers which can be used to capture the timer value on a specific external event on capture pins. For information about LPC 2148 capture operations in input capture mode. Okay, so these are all the timer 0 registers. So timer T0IR, timer 0 interrupt registers, it's an 8-bit read write registers. So next one is the 4-bit consist of match registers, interrupts and 4 bits compare registers. If an interrupt is generated, then a corresponding bit is in this registers will be high, otherwise it will be low. So writing 1 to any bits of the registers will reset that interrupt, writing as 0 as no effect. Okay, so the next one is timer 0 timer control registers. It's a 8-bit read write registers. So bit 0 counter enabled, 0 counters are disabled, 1 means count timer counter and prescaler counter are enabled. Bit 1 means counter reset, 0 means counter not reset, 1 means timer counter and prescaler counter were synchronously reset the next positive edge of clock pulses. Okay, so the next one is timer 0 counter control registers. It's an 8-bit registers. It is used to select between timer counter mode. When counter mode, it's used to select a pin and the edges for counting. So it's having bits 1 is to 0 timer counter mode, 3 is to 0 count input selector. So these are all the timer 0 counter control register format. Okay, so the next one is timer 0 prescaler registers. The purpose of prescaler registers is a maximum value to hold that particular prescaler count. The next one is timer 0 prescale counter registers. It's a 32-bit registers. It's having the peak clock, peripheral clock, by some constant value before it is applied to the timer counter. It's incremented by peripheral clock. When it reaches the value in the prescale registers, the timer counter is incremented and the prescale counter is reset on next peripheral clock. Okay, so the next one is timer match registers. So these are the 32-bit registers. The values stored in these registers are continuously compared with the timer counter value. When the two values are equal, the timer can be reset or stopped, or an interrupt may be generated. The timer counter control what action should be taken on a match. Okay, so these are all the timer 0 match control registers. So this is 16-bit registers. So it controls the what action is to be taken, match between the match registers. So MR01, it's called match registers 0 interrupt, match registers 0 reset, match registers 0 stop. So these are all the timer registers format. Okay, so here I have concluded the timer operations. In the following classes, we are going to see about the pulse width modulations. Okay, thank you.